This model was graciously provided by Merrill Iron and Steel Inc. and Bolt. This was the active project fabrication model that was used for training Bolt. Before I begin, I would like to mention that the fabrication model is extremely accurate. All CNC data comes from this model, and if it were not dead on, the fabricators would be very displeased to say the least. Let's begin with viewing the original fabrication sequences. Unfortunately, in many cases, these sequences will be required to be modified or broken down when it comes to the field. With the status filter, we can see which members have already been fabricated and shipped. After determining the Erector sequence, we may need to reveal our new plans to the fabricator so we can get the steel on site in a timely manner. I will begin by looking at this frame to see which members may be attached to the assembly. We see the beams at the top where shop attached this frame as clearly indicated by the highlighting or the green selection. Let's review the assembly with a double click. All items can be reviewed with a double click. I can also from this location quickly review the 2D drawing or erection view drawing from this location or by using any of the assorted available tools. I am using Bluebeam, which permits me to mark up these drawings. By snapping to the surface of the member, I'll determine the center-to-center distance to the beam, showing that the dimensions can be directly taken from this model. Since I am here, let's run a summary of the field bolts on this particular frame. By loading this pre-saved status filter, you can see in orange any bolts that are 1 1/8 inch diameter. Note, the gray bolts are those that are field bolts shipped with the brace. We'll come back to this with a point-to-point list that can be used to sign off on connections. Members in SDS2 can easily be turned into solid form, transparent, or stick. I'm going to run a tool that will select members with 1 1/8 inch diameter bolts. We can see the list of members that contain the 1 1/8 inch diameter bolts and the selected members in the model. When looking for type and length, you can always double-click the bolts, but we'll generate a point-to-point list instead to get that data. Now, I will add a note with an attachment to this frame. Note how you can find the note in the note viewer, and the view will zoom to the view location. I will now create some Erector sequences by first selecting the members that I would like in the sequence. Then I will save the selection for later use and finish by applying the sequence of the selected members. I will now load a pre-created status configuration that will show each Erector sequence by color. Then I'll modify this and change it so that it will hide anything in the Erector sequence, in this case, sequence 1. Let's go ahead and create Erector sequence 2. I'll finish by turning Erector sequence 1 back to cyan. Time to extract some more data for the field for this work package. First, I'll get a report of the field bolts required per sequence. Then, a field bolt point to point, which can be used for signing off on the connections. Let's finish with a list of members in the Erector sequence for the shop and the field. Let's go ahead and sort this list. I will now create a colorized 3D PDF for the field of the Erector sequence 1 and 2, plus a few surrounding members. Of course, you can do the entire model or just each sequence. That is up to you. I'd like to point out how you can find members in the PDF model or the tree. You can also modify your view. The U3D can also be read on a tablet with the installation of a 3D U3D PDF reader. I will finish this section by creating an IFC for my collaborative modeling software, such as Navisworks, BIM 360 Glue, Tekla BIM Site, Trimble Connect, etc. I'm going to not send the bolts and welds in the IFC just to reduce the size of the file. Note, you can also send the center of mass or gravity in this export. You'll notice all the data that is packed into this IFC. I'm now working in Tekla BIM Site. Here are the sequences, the Erector ones that we created. You can even create a workflow video from your collaborative modeling software if that is supported. This will conclude this video.